Core i3, Core i5, Core i7, Core i9, Core Ultra 5, Core Ultra 7, Pentium, Celeron, Core X, Xeon, 13th Gen, 14th Gen, KFHUT, Alder Lake, Raptor Lake, Meteor Lake. If you've ever tried to understand Intel's full CPU lineup and walked away more confused than when you started, that's not your fault. Intel's naming system is genuinely one of the most layered in consumer tech. So let's cut through all of it, build a complete map, and make every name make sense. The confusion comes from three things stacking on top of each other. First, there's the tier system: Celeron, Pentium, i3, i5, i7, i9. That's about performance level. Second, there's the generation system: 12th gen, 13th gen, 14th gen. That's about when the chip was made. Third, there are the suffixes: K, F, H, U, and others. Those tell you what the chip was designed to do. Three separate systems, all attached to the same product's name, all relevant at the same time. And on top of the mainstream consumer lineup, there are two more families sitting at opposite ends: the professional Xeon line and the extreme enthusiast X series, both operating by slightly different rules. Once you understand each layer separately, the full picture stops looking like chaos and starts looking like structured hierarchy. Before going deep on any one chip, here's a complete ladder. At the very bottom, Celeron, above that Pentium, then the mainstream consumer line, Core i3, i5, i7, i9, and above the mainstream, Core X for extreme enthusiasts, and running parallel on the professional and server side, Xeon. Each tier exists because a different buyer needs a different balance of cost, performance, and capability. Intel isn't releasing random product lines. Every family has a specific target. Celeron, the entry point. Celeron is Intel's most basic processor line. It sits at the bottom of the performance ladder and has been there since 1998. Celeron chips have fewer cores, lower clock speeds, smaller cache, and cuts down features compared to everything above them. They are not built for demanding workloads, they are built for devices where cost is the primary constraint. Budget laptops, basic office machines, school computers, thin clients, entry-level Chromebooks. If a device is doing light web browsing, document editing, video calls, and not much else, the Celeron is sufficient for that and nothing more. Push it towards multitasking, gaming, or creative software and it will struggle. The trade-off is price. Celeron-based machines are significantly cheaper than Core i3 machines. For institutions buying hundreds of devices for basic use, that price difference matters more than performance headroom. One important note: Celeron chips are often several generations behind the current mainstream lineup. You might see a current Celeron chip built on an older architecture, while Core i5 and i7 have moved 2 generations forward. Intel maintains Celeron as a cost-optimized line, not a cutting-edge one. Pentium sits one step above Celeron: more cache, slightly better clock speeds, occasionally an extra core, still well below the Core i3. The Pentium name carries a lot of history. In the 1990s, Pentium was Intel's flagship consumer chip. The Pentium 3 and Pentium 4 were the processors powering mainstream PCs at their time. The name meant something. Over the decades, the core architecture took over as Intel's primary consumer brand, and Pentium was repositioned downward, eventually landing at the budget tier above Celeron. Here's the key update though. Intel officially retired the Pentium and Celeron brands in 2023. New chips are no longer being released under those names. Existing inventory is still being sold and you still find Pentium and Celeron labeled devices on shelves. But going forward, Intel is consolidating the low end under the Core 3 branding. So if you see Pentium or Celeron today, you're looking at a chip from an older product cycle being sold through. Not necessarily bad for the use case, just no longer being updated. Above Pentium and Celeron sits the main consumer lineup. 4 tiers: Core 3 at the bottom, Core 5 in the middle, Core 7 above that, and Core 9 at the top. You still see the older naming: i3, i5, i7, i9 on chips from the last few years. Same logic, just the older label. Think of it like a hotel. Core 3 is standard, Core 5 is business class, Core 7 is premium, Core 9 is the penthouse. Each step up gets you more cores, higher clock speeds, and more cache. Core 3 handles everyday tasks: web browsing, documents, video calls. Core 5 is the mainstream sweet spot, handles most things including creative work and gaming. Core 7 is for demanding workloads, video editing, 3D rendering, serious multitasking. Core 9 is for people who need maximum performance and are willing to pay for it. Most people land in Core 5 territory and never actually need to go higher. The number after the tier tells you the generation. In a name like i7 13700, the 13 means 13th generation. In a Core 7 14700, the 14 is the generation. Generation matters because Intel improves its architecture with each release. A 13th Gen Core i5 will generally outperform a 10th Gen Core i7, even though the i7 sounds higher. Newer generation, better architecture and better efficiency. This is where a lot of buying mistakes happen. People see i7 and assume it's faster than an i5 without checking the generation. The tier and the generation have to be read together. Here's a simple rule. Within the same generation, higher tier wins. Across generations, newer usually wins even at a lower tier. Alder Lake, Raptor Lake, Meteor Lake, Arrow Lake. These are Intel's internal architecture code names for each generation. They sound technical, but they're just project names that became part of public conversation. 12th Gen is Alder Lake, 13th Gen Raptor Lake, 14th Gen Raptor Lake refreshed Meteor Lake. Tau-based chiplet design, late 2023. Arrow Lake was 2024. You continue the Tau architecture, new efficiency improvements. You don't need to memorize these, but when you see them in reviews or spec sheets, they're just generation markers with a different label. The letter at the end of an Intel CPU name tells you what the chip was built for. K means unlocked. The clock speed multiplier is open, so you can push the chip beyond its rated speed. K chips are for enthusiasts who want to overclock. They run hotter and need better cooling. F means no integrated graphics. The chip has no built-in GPU. Cheaper than the equivalent chip with graphics, but you must have a dedicated graphics card installed. H means high performance mobile. Found on performance laptops, gaming and creator machines. More power, more heat and bigger chassis required. U means ultra low power. Found on thin and light laptops. Trades raw performance for battery life and lower heat output. T means power optimized desktop. Lower thermal output built for small form factor systems with minimal cooling. HX is the highest performance mobile class, essentially desktop level chips and large workstation laptops. Read the suffix and you'll know the chip's intended use case immediately. Above the mainstream core lineup sits Core X. This is Intel's high-end desktop platform, abbreviated HEDT, and it operates on a completely different circuit and platform from the consumer chips. Where a mainstream Core i9 might offer 24 cores, Core X processors have pushed to 18, 28 and in some configurations even higher core counts. They support more RAM, more PCIe lanes, and are designed for workloads that consume everything a standard consumer platform can offer, and still need more. The target here is a narrow audience: professional content creators running heavy renders, researchers, engineers, and enthusiasts who want the absolute maximum a desktop Intel chip can offer without moving to server hardware. Core X chips use the LGA 2066 socket, different from the mainstream LGA 1700 socket. They require X299 platform motherboards. This means a Core X build is a deliberate, expensive choice with a platform built around it, not a drop-in upgrade from a mainstream system. It's worth noting that Intel has pulled back on the HEDT market in recent years. AMD's Threadripper has been aggressive in this space, and Intel's Core X updates have been infrequent. If you're building in this tier today, it's worth checking the current competition landscape before committing to the platform. Xeon is Intel's processor family for workstations, servers, and data centers. It runs parallel to the consumer lineup but is built for entirely different requirements. The key difference comes down to four things. ECC memory support. Error correcting code memory detects and fixes memory errors automatically. In consumer computing, a rare memory error causes a crash or a glitch. In a server running financial transactions or medical data, that same error is unacceptable. Core and thread counts. Xeon processors can scale to core counts that consumer chips don't reach. Higher-end Xeon configurations push into 60 and even higher core counts for massively parallel workloads. Multi-socket support. Server configurations can run two or more Xeon processors on the same motherboard, share memory and working together. Consumer Intel platforms don't support this. Sustained reliability. Xeon chips are validated for continuous operation, 24 hours a day, 7 days a week, for years. Consumer chips are tested for typical usage patterns, not constant full-load server operations. Xeon also has its own tiered naming system. Xeon E is entry-level workstation, Xeon W is high-end workstation, Xeon Scalable, labeled bronze, silver, gold, and platinum, covers the server and data center range. Platinum is the top, with the highest core count, largest cache, and most memory channel support. If you're buying a workstation for professional use, 3D animation, scientific simulation, large-scale data processing, Xeon is the conversation. If you're building a home PC or even a high-end gaming rig, you don't need it and the cost of premium won't make sense. One more addition to the modern lineup, Intel introduced Core Ultra branding, Core Ultra 5, Core Ultra 7, Core Ultra 9. Core Ultra chips include a built-in NPU, Neural Processing Unit. It's a dedicated hardware for AI tasks, separate from the CPU cores and the integrated GPU. It handles on-device AI workloads without loading the main processor. Core Ultra is Intel's AI PC platform. If you see it on a laptop, the machine is positioned for AI-assisted workloads, real-time transcription, background processing, on-device model interference, in addition to the standard computing tasks. 3 layers read every mainstream chip name. Tier tells you performance level, generation tells you how new the architecture is, suffix tells you what the chip was built for. For the extended families, Celeron and Pentium at the budget floor are now being retired. Core X is the extreme enthusiast ceiling on the consumer side. Xeon is a professional parallel universe with its own rules, its own platform, and its own use case. When comparing chips, check generation first, then tier, then suffix for use case match. Never judge by tier name alone. A newer Core i3 regularly outperforms an older Core i7. An H-series laptop chip outperforms a U-series chip from the same generation because one was built for performance and the other for efficiency. The naming system isn't random, it's 3 systems layered into one string. Now you can read all of it. Intel's product lineup spans from a $30 chip in a school Chromebook all the way to a server processor running in a data center that hasn't been turned off in 3 years. Every chip in that range has a name that tells you exactly where it sits and what it was built to do. Celeron to Pentium, budget to enterprise, once the map is clear, every name in between makes sense on its own.